Hello, Diogos here. Welcome back to my Factorio series, the Manhattan Project. Alright, we're just going to continue where we left off. So if we just use this setup right now, I put some circuits in there right now, and I'm letting this the clock run right now. You can see it's kind of flickering right there. If we just do this, it doesn't really work because it's only going to check every 200 seconds, right? Right now it's checking, I think, every 5 seconds. Yeah, that's at 300. Yeah, so that's 500. I mean, that's 5 seconds. Remember, it's 60 ticks per second. So we don't really want that. It's checking also here, by the way, if A is greater than 0. So that's pretty much always true, unless I plug this in at night or something. So you can see it's working. This is kind of what I've expected. This would be correct if we wanted it to only check every 200 seconds, but that's not what we want, right? So let's turn this off, and we can do that by. Actually, we can leave that on for right now. What we'll do is think about what we want to happen. We want the whole system to be off while it's just sitting here and waiting for the accumulator to get below 15%. And when that happens, we want to send two signals. We want to send a signal to run the inserter once, right? And let it do its one insert, and then turn on the clock and switch over to using this logic here, right? So this is all fine and good, but we need to add a little bit extra stuff to make it work. And that extra stuff is going to be, we want to send a single pulse. So essentially, if we get an on signal, right, from the accumulator being less than 15, we don't want to have a signal going over here turning this on for as long as it's less than 15. We just want a single pulse, and that'll handle the very first time. And then afterwards, it will be handled by this setup down here, essentially. And the other thing is, we may not even need to turn on this clock. We could probably leave it running, but we'll see. It might do it twice. I'm not sure yet. So let's first do the pulse steal, right? So the pulse steal is pretty simple. You get a couple of your deciders. Okay, we'll put them right here. This is not how it's going to be laid out, remember. We're going to fix that. Okay, so this is not exactly ideal. Everything is kind of let's move this over a bit just so we can hook things up a little bit better. Put it right there. Will that reach? I'll reach. Okay. So A greater than 0, output P of 1, okay. And why is it not running? Because it's because it's not hooked up to this, right? Of course. Okay, there we go. Now that should be P is 1, all right. And you see, every 5 seconds it's going to run again. Okay. So that's what we want to see, except for the first time it runs. And so now get your couple of deciders, two deciders, and we'll put them right here. Okay. Kind of right next to each other. And let's see, this is doing P is 1. So we can output that up here. And just connect them up to both of the inputs for these deciders. So you can see P is 1 for both of those. For the bottom one, we'll check to see if P is less than 1. Then we'll output something here. And we need to use a green wire for this part. Then we're going to insert that value up to the top decider, feed it into that, and this one's going to be similar. It's going to be P is greater than 1. Okay. And Then from here, I think we can connect this straight up that. And let's see, P is 1 now. Okay, so it's kind of hard to see because this is a pulse, right? So what I'm going to do is I'm actually going to disconnect the accumulator because it's hard to control that. And I'm going to use a constant combinator. And this constant combinator is going to just be like a simulator, right? We'll hook that up here. Okay, so this one is checking for A. Let's say A is less than 15. I mean, it doesn't really matter actually what we're doing here. Okay, and then what I can output is A of some number less than 15, say 10, and now it's like the same as the accumulator being always above 0, right? So it's kind of, now we're equivalent to what we just had it. Let's move this back over so it has some stuff to move. This is just so I can see it in action, right? Okay. So now it's kind of back to the way it was, but we can turn it off now, like that. So now the whole thing is off. P is 1 because of the clock. No, the clock's off, right? No, the clock is on, right? Okay, so the P, so that's still going. And P is 1 from here because we're getting A is less than 15. Here, let's this is probably because A is 0 right now. Let's change this to equal 15 for right now, and change that to 15, 20, 10. Okay, same thing here, 10. Okay, just some value, right? Okay, so now it should be off. All right, good. Yeah, so sorry, it was just still sending the signal. So now I can switch it on, and it should run its pulse, and then run again after 300 seconds. Okay, so let's test that. We'll turn it off. And the way we can test this, we'll move these back out just so we can be very clear here. Yeah, the way that we can test this is actually change this to something more than 5 seconds, so it's a little clearer. So we can do double that, right, and make it 10 seconds. I think that's just from my sanity. I want to make sure it works. So we send a pulse up through here, and we send a constant state through here. Okay, so you can see right now there's no signal coming out of this one. It would be P1 right there, right? And then there's nothing here. And right here, if it gets to 600, it flashes P. So this one will flash P, but it's only 1. This one will get P of 1, right? Every 600, or every 10 seconds. So we're going to simulate that the accumulator is dipped below 15% now, constantly, like it's 15, 14%, something like that, right? And what we should see is, and you know what, let's just make it a little easier to see because I can't mouse over while it does it. We'll hook this up to a lamp right here as well. Okay. And this one's outputting, oh, it's not outputting anything. Dang, that's the problem. Okay, so I need to output P is 1. That's my problem. Okay. I mean, that is an additional problem. And P is 1. Okay. That's good. And now this one's enabled if P greater than 0. Yep. Okay, and let's make it, let's not do that. Okay. Now it should, once you see that lamp flicker, this move, and then problem is, okay, I see another problem, but we're just gonna test this real quick. Okay, flick. Uh-oh, it's still on. Something's not right. Now it's outputting P is 1 because we're still getting an input signal here. Let's see, what did I do? Did something wrong. Okay, so this is getting P is 1, which is correct, right? This is getting P. Input signal P1. Why is that P2 and that one's P1? Wouldn't that be the other way around? And this one's constantly P2 because P1 and P1 from here, right? First of all, yeah. So something's wrong with this part because this should not still be on. So let's think about this. What did I do wrong here? Less than P is 1. I think this is right. And P greater than P is 1. Let me hook up this because it might help me see what I did wrong here. Let me hook this one there. P greater than 0. Okay, so that's kind of what I expect. Let's switch this off again. Okay, that's what I expect. I expect this one to be constantly on, right? Because P is right now less than 1. It's 0, right? Because it's not getting anything. Oh, that's why. It's, see that light flicker every few seconds? Let's do it like that. See it flick? Yeah, it's because I connected this up along the same circuit. That was stupid of me. Okay, I can fix that. Let's go back to where we had it before. Okay, so what's the easiest way to do this? Is there really no way I can disconnect circuits? Let's look in the controls. I always forget to look that up. Anything here for shift clicking? Remove pole cables, shift left mouse button. Yes, I was expecting something like this for remove circuit cables. I mean, I guess that's fine. Okay, back to this. Doesn't really work. Okay, pick that up. Somebody please tell me. I'm gonna have to Google this if I remember. I never remember. Okay, back to what we were doing. P is greater than 0. P is greater than 1. Output P 1. And now what I should do is hook this up with just a different color. That's all that really matters. Okay. So now if I flick this on, I should hopefully see a pulse. Okay, I did not. Oh, I haven't hooked this up yet. Let's turn that back off. Okay. Run this one. This can be the same color because I want it to get the same signal. And then using a different color for right here, we want to take the input or the output from the bottom one, the less than one, and put it up into the top. Okay. Now it should work. There it goes. There's the pulse. Now it should wait 10 seconds. And we're pretending like that's 200 seconds, right? Thank you, bot. And go. 10 seconds. You see it pulsed again, though. It did pulse again. I'm going to change this to something faster. See, it pulsed again. Okay. Why did it pulse again? Oh, it's because this one is sending a different signal, too. Right? So it's sending... It's sending another P1 signal down this line. That's what it is, right? Of course, of course. Let's fix that like this. Okay, so what did I say this was? A equals 10. So A equals 10. Output P of 1. So again, I hook that up, and use a different colored cable. And that should be fine because you see this one was a problem because it was, even though it was passing through here, it was going into an input. This one's going into output. So the only input it's going to is right there. So let's turn this off. Turn it back on. There's the pulse. Now we shouldn't see, let's drop this down to say 200, so every few seconds. Turn that off again, test it out, nothing's happening. All good. Pulses, now like 1, 2, it should run again. 1, 2, 3. Like, what is 200 seconds divided by 60? It's a third of 5. Okay, or 2/3 of 5. Yeah, so I think this is working, except one problem, if you notice, is that if I stop this, right? So let's say it has a problem, it does its thing, and then it climbs back up, and then again, like the next night or something, it has another problem. That clock is stopped at, or it's not stopped, but it's whenever I go and flip that switch, it could be at y equals 1, or it could be at y equals 199, right? If it's or 12,000 or whatever the number is that we're counting up to. If it's 200 seconds, it'll be 12,000. But it could be like 1 second away from completing, or it could be the full amount, or anywhere in between. And that gives us a problem, because what will happen is if it's 1 second away from being done, it'll pulse, right? Move over a fuel cell, and then it will pulse again right away, because it'll be 1 second away and it finishes, right? It's not starting from 0. Okay, so in order to reset the clock to keep it from accidentally triggering too soon, what we can do is change this first decider here that we put down, right? Right now it's just set to our two variables, which is x equals y, x is 0, y is 0. So since there's no values for them here, it's always true. X is 1, that's now times 300, getting passed on the line, right? If we can see that if I change that to 0, and the clock still runs, everything looks good. We can change this to j, some random variable, still good, right? Okay, so essentially what we want to do then is pass in some truth test here that will allow us to set this back to off, right? So if it's not true, like say it's set to 0, what happens is the clock doesn't just stop, it gets reset. Okay, so what we can do, let's see if P from here, I think, is the way to go. We'll just connect this up. We can use red wire, I think. Yep. Hook that up, and we'll say P is equal to 1. And right now it's off, so that clock got reset, right? So let's see, I want to put a lamp up here to kind of see this, if it's running or not. Let's look at if y is greater than 0. Okay. So it's on while the clock is running, essentially. Okay. So we'll switch this on. Now it runs, and we can see that had started over from the beginning. It came up to 300. Flick there, that's good. And then when the accumulator goes back to being above 15%, clock is off, 0, and then when it restarts again, pulses, starts back up at 0, right? No matter where it is in the cycle now, it will always get reset. So actually we don't need to use this one because we're using this one, right? This one would stop the clock, pause it, but not reset it. This way resets it and stops it at the same time, right? So we can fix that by just connecting this up directly like that. And now the clock is back to going. Switch this back off. Everything is working the same. All right, that's great, fantastic, wonderful. So now we have a system, and there might be a way to do this logic better, you know, maybe with fewer deciders or something. I don't know, but I like this way because I can easily control the time that I want. I can reset the clock this way, and I can get multiple inputs, have a pulse, right? So everything's great. In the episode here, and in the next episode, we will collapse this down and make a pretty design for us to fit next to, you know, our reactors. Now, the way it'll work is, you know, we'll have our reactor somewhere like, okay, that's it's off. We'll have our reactors like this going up, say, and this will be on the top of the bottom. Well, it'll be condensed down, and then remember that's the reactor, right? And these are the chests. So we'll run this in series if we had, you know, multiple, just like this. We just kind of run it along the line there and copy and paste the condition, right? So if green is go, if we're good to go, then we will run. So let's just test that there real quick before we leave. Okay, so it does its pulse. Now remember I said with more logic you could control how many reactors get turned on at once, but we're going to treat this power plant as a single unit for this game. So it's 8 fuel cells at a time, no matter what. Oh, all right. Well, I like this. So thanks for watching, and I'll catch you in the next episode.